Hello everyone, this is the final video of Hydra Book Reading Club, and in this video I'm going to continue on the topic of custom GLSL. By the way, I couldn't book the normal recording room studio, so I'm just doing it in another room, but hopefully that's not a problem. Anyways, I'm just going to be like tiny window on the corner, and the topic is about like me coding the custom GLSL function, and in this video we're going to tackle the last one. So we're going to go to the API page that is also linked down below in the description. We explored so far 4 types: source, which is actually called type src in the Hydra like set function world, and geometry, which is type coord, color is type color, straightforward, blend is type combine, and modulate, the last one, is called combineCoord with a camel case, so the chord C is capital, and basically it's a combination of blend and geometry. And we're going to look into it. And again, this video is like super advanced. Well, it's not super advanced, it's about like combination of different tools we're going to be using. So if you're new to Hydra, maybe this is not the video that you want to watch first. There are beginner's tutorial, intermediate tutorial that I recorded in the past that may be a good starting point. And also in this series, I say every time, but the custom GLSL chapter, I'm not explaining how GLSL works. And in the video, I assume that you have like basic understandings of GLSL, because this is different from JavaScript or Hydra. It's completely something different, but something that Hydra uses. Hydra basically analyzes or compiles or put together the code from your OSC, color, colorama, blend, noise, whatever, that is like compiled into one single GLSL code, and that will be passed to the GLSL or WebGL compiler, and that generates the images. So it's very like technical things we're doing here. It's quite like advanced, or how to say, low level, whatever you can say. But it's like very different from like how we write Hydra. But if you're really curious about how Hydra works, this is the like right place you're in, because basically if you want to understand the behavior, like small like tiny behaviors, like things about Hydra, deep into Hydra, you have to like understand GLSL code. And also like in the description down below, I have a link to this GLSL function.js file, which we're referring to every time in this chapter of custom GLSL, because what I'm going to do is not like writing functions from scratch, but I'm going to just take, for example, if I want the Voronoi, I can copy this object. Again, this curly braces is not really matched with the proper indentation, so it's a little bit confusing. And Voronoi is quite like a big GLSL file. You can see GLSL is just like an object of this JavaScript, JSON. It can be JSON actually, because it doesn't contain any like code, right? It's just like strings and numbers, and GLSL is just like a string, like multi-line, but it's just a string that's treated in JavaScript. And inside Hydra, under the hood, it's combining all these GLSL snippets, the strings, all together, from collecting from Voronoi to, I don't know what you have, like Luma, Mask, OSC, whatever. That's all like put into like one single file, and these are the ingredients of that final GLSL code, which is probably like not really readable for humans, because it's like just like putting things together automatically. I mean, inside Hydra. So what we see, what we're interested in is these snippets, and we want to like tweak them and do something interesting. So since I already know it's called combineCoord, actually there's like a list of types here. Source, coord is the geometry, color is the color, combine is a blend, and combineCoord we're looking into is modulate. Also, this is actually a good list because I explained in the video, but basically source, the argument you get like automatically is the position of the pixel, and you return vec4, which is a color. So it's basically source doesn't precede, or no, succeed, or how to say, that doesn't follow any other function. Source is like something standalone that comes from the beginning. The only information it has is you have this pixel, what's the color of it? And the pixel meaning that the xy coordinate of the pixel, which is this vec2 st. Given that, what's the color? And that's the only information. Plus, like, you have like global variables like time that you can use, and also you can pass some parameters to it. And for example, coord, this is the recap, but coordinate function is basically you transform the argument vec2 into another vec2. So xy position, given that, return a new position. But it's actually not like translate that P5JS, for example, or processing that you translate this position to that position. But I think it's the other way around, because it's like it's a matter of sampling instead of moving the pixel. Anyways, you get a vec2, you return a vec2. Color is quite straightforward. You get vec4, so you get certain color as an input, and you return another color. So if you want to enhance the brightness, you maybe just want to multiply the input color by, I don't know, 2, or by the argument of this function, and return it as color. So it's very simple. And also to note that, for example, coord, if you use this function, they don't have any information about color. It's just about purely about xy position and new xy position. Color is the color, the vec4 RGBA, you get it, and you return RGBA. So if you use color function, if you define a new one, you don't have any information about the position of the pixel, for example, because that's not passed as an argument. Combine is something that you have, for example, OSC blend Voronoi. That's what we saw in the last video. So the arguments you get are underscore C0, which is the color of this function that comes before blend or before the combine function, and color vec4 of underscore C1, which is the function inside, like passed as a parameter. So if you have like OSC blend Voronoi, that's Voronoi is the C1, and you only get the color of that Voronoi function, and you have these two vec4s, which are two different colors, and you do something about it. You can like mix them, like, you know, take an average, that's like a blend function. You can mix them with like taking minimum, maximum, which we explored a little bit in the last video, which is not offered by Hydra itself. So this new things you can try if you define your new function through set function. But again, also to note that this, if you do combine, you don't get any information about the position, the coordinate xy of the pixel. You just get color 0, color 1, and you do something to return a new color. Now, modulate is a little bit more confusing because, okay, and also like I need to like try things out before I explain what this chunk means, because it is very confusing. And that's why like always like modulate is something that is like very counterintuitive. If you want to just like put things into modulate function, put noise, you know, modulate noise, boom, that's always fun. But also like to explain actually what is happening under the hood is really hard, and I also get confused. So I don't think anyone in the world can really like precisely explain what is happening here. I mean, okay, maybe you have better understanding of it. I'm sorry, then please like give me a good explanation of modulate in the comment down below. I appreciate it. Not being sarcastic, but I really need like a good explanation of modulate rather than, you know, like just saying like, okay, just put noise and it's gonna be fun. But let's look into it. I think it's a good idea to actually tweak this modulate function and see what it does. And actually, if you look into modulate function, it's very simple. It's just this. Also, like GLSL part is 2 lines, but actually the one is like commented out. So it's just 1-liner. And as always, I'll just like delete this and then set function. This is where we start. If you want to define a new GLSL function, or Hydra function as, you know, GLSL snippet. And So again, like modulate is the name. We're gonna like put modulate 2 because we don't want to pollute the Hydra, what's offered by Hydra. We just want to like separate it because we can actually overwrite modulate like this, but that's gonna be confusing. If you want to do it, feel free to do it, but I'm not gonna do it for it's for the description. And again, type is combineCoord. Now, as you know, modulate takes 2 inputs, but it's like one is like implied here, which is the other function. So if you can put like modulate noise, that's automatically like given that because we're talking about combineCoord, we don't have to define this like the texture is here. It's always given. So that's that. So hidden function argument here, or texture argument here. And then there's the second one, which is the amount. Like we know that always the default is 0.1. Sometimes we want to make it super small, like 0.01, 0.003 or something that I usually use. But also like I go like sometimes really wild, like if you want to do like color remapping, which I can actually also explore now. In that case, I would do like 1. That's like big number for modulate, but default is 0.1. And this is really like arbitrary number. Like it doesn't have to be 0.1, but it just happened to be 0.1 that Olivia Procli wrote. That actually works. So if you omit this number, it does work. Because if it's like 0, then it doesn't do anything. It's not exciting. So I think it's a good number. And if it's 1, it's just like going too wild. So like it's kind of adequate number, like educated guess, whatever. So I'm gonna just take this part out because this is just like commented out. And I think the difference between them is like somehow like the original implementation is taking like a fraction of the calculated coordinate so that it's kind of wrapping, like I talked in the video like two videos ago, the previous one, I talked a bit about like how to make the scroll X not to repeat or repeat in like mirrored way. So fract function is something interesting, important to use in that sense. But I'm gonna just take it away. And also like the reason why always like I do like modulate solid blah 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 blah, it's like super long code to make it not repeated scrolling is because this doesn't have fract in here. If it has fract, it will just repeat it. But since it doesn't have it, it doesn't repeat the texture, and that's sometimes really handy, sometimes not. Okay, so enough talking. It's very simple, and actually in this Hydra book reading club, if you watched all the videos, I don't know if you watched all the videos, but in the modulate chapter, I talked about how modulate works with P5.js. So if you're curious about like how actually modulate works, that's the video that you want to watch. But basically, it's in the video, I'm just explaining how it works, basically deciphering what this means. And here, _st, so if you're like, now probably you're familiar that st is, when I say like xy coordinate on the pixel, that's st, because I think in GLSL they kind of separate xy and st because xy kind of implies that in a 3D space, x, y, z, w, but it's st or uv coordinate, maybe that's more familiar for some people. That's like, 2-dimension space, so it's like a plane on the screen, for example. So _st is the position of the function that's inside, if I understand correctly. So if we have, let's say, OSC modulate, just simple, right? We know how it looks like, kind of. And I'll just stop it because, and also make it a bit more sparse so that it's not really, blocking the vision. If it's like really fine texture, it's kind of like annoying when we're like reading the code. So I'll just keep it like this, just, arbitrary number again. And also like this is implied 0.1 because this default value is 0.1. Now, what this does is, okay, let's go back to this file. And we had this place here at the top that says, okay, types here, combineCoord return type vec2. So vec2 automatically means in Hydra GLSL it's returning a coordinate. So it's st or xy, whatever you want to call, uv, and the arguments are another st and underscore c0. So you're given a vec2, like a position of the pixel, and a color. And that's this color is the tricky one, because if we're just like given vec2 and returning vec2, it's just like coord. What it does is like you get position of the pixel and you return a new position of the pixel. If it's like inverted or whatever, like, but it's straightforward. That's kind of like pipeline wise. You get position and you transform it to another position. What it does with modulate or combineCoord is, in addition to that, we have this underscore C0. So if you look into this, what happens here is ST here is the position of the pixel, and here we have this underscore C0, which is the color of this function. So it's actually really confusing, because in the blend world or the combine world, what we looked at is like we had underscore C0 and underscore C1. And underscore C0 is this part, and underscore C1 was this part. But in combineCoord, now things are shifted because of, I don't know, just how it's done. Underscore C0 is the color of noise. And the color of noise is basically changing the position of OSC. So it's not changing the color of OSC, for example. Like if I have, for example, like gradient here, it doesn't give like black or white, which noise offers, right? Noise is like, well, it has like negative number as well, but basically it's grayscale. But if you do gradient modulate, and even if you like amplify this a lot, well, actually we start to see black, but this comes from the gradient itself, because gradient has like black to like red, green, yellow. And what happens here is that the color of gradient doesn't change. So it's actually what modulate does is just like you have, I don't know, scroll X, because scroll X doesn't change the color of gradient. It shifts a lot. It's kind of drastic change, but the color palette, the color, you know, the ink, or like, I don't know, like the color palette that gradient has, it doesn't change with a chord function. If you do scroll X or if you do like repeat, it's always the same color palette of gradient. Rotate, doesn't matter. All these like chord function, it's just about like changing the coordinate itself. So like it's kind of like shuffling all these pixels and, you know, putting into the right, well, new place. So it's like doing this puzzle, but all these pieces, all these colors doesn't change. And it's the same with modulate. And this, I think this is the key to understand this, because if you do modulate, for example, like, and also we can flip this, right? So if we say like noise is here and noise is like grayscale again. So if we do like gradient as a modulator, it doesn't change the color palette of noise. Even if you put gradient here, it doesn't really add the color of gradient, and it doesn't matter if you like really make it big, it doesn't matter. It will not change the noise color palette itself. Why is that? Because essentially what combineCoord is doing is just like the chord, so geometry function. It's basically just changing the geometry. It's like just like scrolling, just like repeating, just like rotating, but that's not changing the color, right? So, but what's tricky here is that we have this new actor called underscore C0. This is the color. So why are we like using the color but not changing the color? Because we're trading this underscore C0 with XY, which means that we're only taking the red And also like this is the same as RG, right? If you take XY or RG, it's just getting the vec2. And GLSL doesn't really care if you're talking about color or XYZ or ST or whatever, like these, it's just about the vector. So what matters is that you have the proper vec2 or vec4 or whatever that's like defined. If it's like aligns in that space, the slots align, then it doesn't matter if it means red or if it means X or if it means blue. These things are just like, for the compiler, it doesn't matter. As long as if it's vec2 and defined as vec2 and we're inputting vec2, it's fine. Doesn't matter if it's color or not. So here, we're kind of like mixing up now in an interesting way that ST is the position of the preceding one here. So it's basically just like how we're doing like scroll. It's just converting ST into new ST by adding underscore C0, which is the color of this. Because also at the same time, we don't have information of the coordinate of this. I mean, it doesn't really matter. Like, it's not like ST0, ST1. Like, I know blending is like, we have underscore C0, underscore C1. It's very straightforward. We have two colors, do something about it, and output new color. Now, we're not like talking about ST0 and ST1 because it's just like that's not how it works. We're talking about this ST of noise and underscore C0 of the gradient. And there's like super interesting experiment we can do. What if we just like simplify this so much that one way of like simplifying this is like, for example, the boring version is just return ST. What would that do is, and I will just like flip this because, or like maybe I'll just go back to the OSC example because it probably illustrates better. So instead of modulate 2, I'll just do modulate first. So this we know, right? We're modulating OSC with noise. Like, we have seen this. And if we have this modulate 2 that just pass-throughs ST, what it does is basically it's the same as modulate noise with 0. Oh, I should be taking this. It's the same result. It's just pass through, like not modulating. I'm not interested in modulating. This is not that interesting, I know. But another thing we can do is, what if we just pass through the color of noise? And here I will not take the amount parameter anymore, just for simplicity. Maybe I can even take this out. And so what if I have this underscore S0, underscore C0 as a pass-through, but it doesn't work this way. I will just try it, but if I open the console and if I evaluate this, it worked because I didn't use modulate 2, and it will do this weird stuff because it's broken, because what combineCoord is expecting is returning vec2, like ST was vec2, so it worked, but C0 is vec4 because it's a color. It has R, G, B, and A. So what I need to do is just like in the original code, I will use C0.xy, which is same as RG. It's just a convention, like, for the coder to understand. Is it X? Is it R? Are we treating this parameter as color, or are we treating it as XYZ? But now, like, we're really mixing up color and XY, and this is why modulate is so difficult and so exciting to explore, because it's just so confusing in an interesting way. So what happens here is that, okay, I did modulate again. I'll do modulate 2, and what is this? This is something funny, and I think it's going to be better to like expose something like this, OC6, and now it looks like almost like original noise. And if I put like colored OSC, so something like this, and I explored this in the modulate, or it was the color chapter of Hydra book, that I make this palette with OSC, and do something with modulate, something sub gradient to do some color remapping. And what happens here is exactly the same, which is just like color remapping of noise into the color palette. Again, this color palette doesn't change. Even if you use noise as a modulator function, it doesn't introduce the color of noise. We're talking about underscore C0, which is a color of noise, but it's not adding the color of noise. It's just using the color of noise as a new coordinate. What does it mean? I think that P5JS video will help a little bit, but what happens here is like it's basically just remapping the color. So I can also name this as remap if we want to like reuse this, and it may be really helpful because it's really like useful and this is really concise. If we say like Voronoi here, it does like take the OSCs, like colorful OSCs, color palette, and using that to color Voronoi based on the intensity of the Voronoi, for example. Well, to be, I don't know, to illustrate it. And we don't have to do like, it's going to be the same if you do like modulate, Voronoi. That's something I explained in the previous video, one of the previous videos. Sub, gradient, closing sub, comma, 1. This lengthy one, it does the same thing. But if we define, because this is really cryptic, like I remember this by heart and I use this a lot because always like doing set function is, that's also cumbersome. And, you know, also like writing this, I make some mistakes sometimes and that might lead to a funny result. Like what if I forgot 1? Okay, this is maybe not, but it's actually quite interesting. Like this Voronoi is like burned into this texture kind of. So I like these accidents, so I like to like write it every time. But if we decide, okay, remapping is like super useful, so we just like take this code snippet somewhere, and if you do like live coding or whatever, creating textures, you can just paste it, and let's say, okay, I do OSC, remap, Voronoi, boom. Or you can like remap another OSC as well, which is like really interesting in a different way. So basically what combineCoord does is like, it's like mixing up XY position and color of this and generating a new XY position. So it doesn't change color, it doesn't change the original color of what's available in the original texture, but it just like changes the position, just like scroll X or repeat. And one like interesting and useful example with this is the color remapping that, as we just saw, if we just define this function, then you don't have to do this, all this crazy sub gradient, whatever, in order to make the same effect. You just have to do remap noise. So it's very simple. And for example, if you do like scale 2 or something, then you can like, this is something I explored already in the one of the previous videos, that you can kind of fine tune the scroll X, for example, fine tune the color palette somehow. So that's something you can explore. Oh, like, I mean, there's like weird spots here, but that's okay. It's just for demonstration. So I hope this is somehow useful. Again, this combineCoord is very confusing, but I highly recommend going back to the example, the modulate function, how it's written, and what if you change this? What if also like you can do is like, what if we take like green and blue? Doesn't really change. Green A doesn't change. A and green, okay, it's the same color because noise, RGB, they are the same, that represents noise, but A is always opaque, so it's always 1. So this doesn't really give interesting result. But what can you do with like, given this underscore C0 has like 4 numbers? What if you also take into account blue channel or alpha channel? And one of the examples you can check is like modulate hue. That is like a very special one that takes underscore C0, the color of like noise or whatever that's modulating, like inside modulate hue. It's taking underscore C0 G, R, and also B here. So it's not just taking the color of like red and green channel of the noise. I mean, in this case, noise anyways has, same value for RGB, but what if you pass this inside there and okay, this doesn't really matter, but if we switch this, then colors start to change. And you can explore all these things. For example, by starting as a starting point, you can just feed this in there. And if you change order or if you change some parameters, multiply something, what if you completely omit R channel? And that I hope that will help understanding how modulate works. And in the future video, for now I'm like finishing the Hydra book reading club series here, and I might start a new series. Something about Hydra. I have some ideas, but I'm not like announcing it yet. But please let me know if you create something interesting. It's a comment down below if you have questions, suggestions, what you want to see in the future about Hydra, about whatever I can do. But yeah, suggestions are welcome. You can also find my contact somewhere here or there. So I hope that this series helps like creating interesting things, and that's something makes me happy to see what people create. And by the next video I'll say happy coding, and yes, I'll hope to see you in the next series. Bye.